Hello. A couple of you asked me to make this video showing the problem on page 8 of the distance learning packet where friction of the SUV going around the curve, the frictional force between the tires and the roadway acts as the centripetal force and allows the car to not go straight but to make the curve. You know, that's true when you walk as well. If you want to suddenly turn, or you are a speed skater and you're skating and you're turning, whether it's your feet on the pavement or floor, whether it's your skates on the ice, your change in velocity is toward the center, as we saw in a prior video, and therefore your acceleration is toward the center, and so the force that acts to allow you to go around the curve is toward the center. In the case of a car on a curved roadway, on a flat roadway anyway, that force is the friction force. The problem reads, imagine you are driving your car around a flat, curved highway near Lake Tahoe. The radius of the curve is 88 meters. Because of snow over the last several days, the road has hard-packed snow on it, and the coefficient of friction between your tires and the roadway is 0.74. What is the maximum speed that your car can be traveling at and still safely negotiate that turn? And a hint is provided. That hint, of course, is that the force of friction is mu Fn. Let's make a list. So our list sort of looks like what we just read. The hint that friction is mu Fn and perhaps an important force leading to the circular motion, the radius, the coefficient of friction, and we want to find the maximum safe speed to drive. Certainly you can drive slower than that, but what's the fastest you can go? Just drew a little picture of the roadway with the centripetal force, which is always mv squared over r, acting toward the center. In this case, the centripetal force is provided by the friction force. And so mu Fn equals mv squared over r. Again, in other words, the centripetal force is, in this case, the friction force. Just a little quick reminder, on flat ground, gravitational force, the weight, mg, is the normal force. They have the same size. They are equal in magnitude. So if mg is 1,000, the normal force is 1,000. So I'm going to replace the normal force here with mg. Now, we are not given the mass of the car. And if we were, we could plug it into both sides. But because, again, it's going to be on both sides, it cancels anyway. And we can eliminate the mass of the vehicle. I'm going to rewrite this just to make this look a little bit clearer to you. Mu times g equals v squared over r. I'm going to multiply by r. And when I do, the r cancels from the right-hand side, leaving v squared equals mu g r. Taking the square root of both sides gives us v max, in this case, equals mu times g times r. Let's go ahead and put in our values. I'm going to run the numbers on the calculator. The result of the calculation is that the maximum speed on this day with this coefficient of friction on Earth is 25.262 meters per second. And we had 2 sig figs in all the numbers we were given, so this just rounds to 25 meters per second.